Alkyl groups with 3 or more carbons can branch themselves, adding another level of complexity and needing us to develop some more nomenclature conventions for them. So, as an example, we're going to start with the following 2 compounds, which I'm going to label A and B. Okay, so if we consider how to name these compounds, we're going to start with A because that's one that we can already handle with the rules that we know. If we count how many carbons there are in the longest chain, there are 10 carbons in the chain going from left to right. Therefore, this is a decane derivative. And the substituent is a propyl group, a 3-carbon group coming off of carbon number 5. Okay, so naming this molecule is fairly straightforward. It is simply 5-propyl decane. Now, structure B also has a 3-carbon group coming off of carbon number 5. Okay, we're going to add the same general numbering scheme. But clearly, we cannot call structure B 5-propyl decane because I said back in the first lesson on this topic that every compound must have a unique name. And if both of these compounds were 5-propyl decane, that name would not be unique. So we need to figure out what to do with this 3-carbon group coming off of the side chain, as a side chain off of position 5. So the way we handle it, at least systematically, is we say that the longest chain that's part of this substituent is a 2-carbon chain, or an ethyl group. But coming off of carbon 1 of that 2-carbon chain is a methyl group. Therefore, this group is a 1-methyl ethyl group. Okay? And therefore the name will be 5 open parentheses 1-methyl ethyl close parentheses decane. Okay, so parentheses, yes, we use them here to differentiate the numbering of the alkyl side chain from the numbering of the main chain. So the 1-methyl ethyl is the side chain and it goes completely in parentheses. And secondly, note the numbering scheme of the side chain in red. The side chain is numbered such that carbon 1 of the side chain is bound to the parent chain. Carbon 1 of the side chain is not on the parent chain. The parent chain has already been numbered, and that carbon on the parent chain is carbon 5. Coming off of carbon 5 is a side chain that has 2 carbons in its longest chain, and it is carbon 1 of the side chain that is bound to carbon 5. Okay, so as you do practice problems with these types of molecules, you will get this naming convention and the side chain numbering convention. Now, 5-1-methyl decane is not the only name for compound B. And as I say it, and if you practice saying it out loud, you'll realize that this name is somewhat cumbersome. So, in situations like this, there are certain branched alkyl groups, such as this one, that occur very frequently. So as a result, we have developed a series of common names that we use to handle these frequently occurring 3-carbon and 4-carbon branched side chains. Okay, so 5-1-methyl decane is the systematic name, but the common name for a 1-methyl ethyl group is an isopropyl group. Okay, I am sure you've heard the term isopropyl before because the typical alcohol used in your house, rubbing alcohol, is also called isopropyl alcohol. And that's because it has 3 carbons with the OH on the central carbon, as we'll see when we get to the topic of alcohols. Okay, so if we wanted to name this molecule with its common name, instead of saying 5-1-methyl decane, we would simply call it 5-isopropyl decane. Advantages to this are, first of all, it's less cumbersome to say. If you say 1-methyl ethyl too many times, you will get yourself tongue-tied. And secondly, and more importantly from my perspective as a chemist, is it preserves information about how many carbons there are in the side chain. One methyl ethyl might lead you to believe that there's only 2 carbons in the side chain, and you have to think a little bit to realize that there's actually 3 carbons in the side chain. But isopropyl is telling you, the propyl, that there are 3 carbons. Iso simply means that it's different from the linear or N-propyl group in structure A. Iso, of course, comes from the Greek prefix meaning the same. And the way you always remember iso groups, whether isopropyl or isobutyl, as we'll see on the next slide, is that the end of the molecule has 2 methyl groups on it, so the 2 sides of the end of that chain are the same as each other. Okay, moving forward to 4 carbon groups, we now have 4 examples that we need to consider: molecules C, D, E, and F. Once again, just like molecule A for the 3 carbon groups, molecule C is fairly straightforward. All of these 4 structures have 12 carbons in their longest chain, so they are dodecanes. However, I added the twist to these that in order to get the substituent to the lowest possible number, we have to number these chains from right to left. If we numbered this chain in molecule C from left to right, the substituent would be on carbon 7, not on carbon 6. Okay, so the substituent coming off of carbon 6 has 4 carbons, therefore it is a butyl group, and this molecule will simply be called 6-butyl dodecane. That one should be easy to you by now. Okay, so what do we do with D, E, and F? Well, we can apply the same parent chain numbering scheme to all of these. They are all dodecanes, and they all have a 4-carbon group coming off of carbon number 6 of the parent chain, except in the cases of D, E, and F, the side chain is itself branched. Okay, so let's look at molecule D a little bit. If we look at its side chain and do the same thing we did with molecule B, the longest branch on the side chain is 3 carbons, and coming off of carbon 2 of that 3-carbon branch is a methyl group. Therefore, the side chain here is a 2-methyl-propyl group. So the systematic name for this is 6, and then in parentheses, 2-methyl-propyl dodecane. For molecule E, we have the same 3-carbon branch, the same propyl group, but now instead of the methyl coming off of carbon 2, the methyl is coming off of carbon 1. So therefore this molecule will be named 6, and in parentheses, 1-methylpropyl dodecane. All right, what do we do with F? Well, the longest branch is only 2 carbons long. Coming off of carbon 1 are 2 methyl groups. So now we're pulling all of these rules together in coming up with the name. So that group is, again, 6, and then in parentheses, 1,1-dimethylethyl. Okay, the ethyl is the longest branch on the chain, but on that ethyl are 2 methyls on carbon 1. Therefore, it's 1,1-dimethylethyl dodecane. Well, if you thought 1-methylethyl was a mouthful, 1,1-dimethylethyl is really a mouthful. So thankfully, we have common names available for all 3 of these groups, and these are other names that you should know. So back to molecule D. For the 2-methylpropyl group, the common name for that is isobutyl. Again, preserving the information that this is a 4-carbon side chain and using the same iso that we saw for isopropyl. And again, think about it as having two equal ends of that branch, or if you prefer, think about the isopropyl and isobutyl groups as having a fishtail. The difference between the isobutyl, of course, is that there is an extra carbon, specifically carbon 1, that's bound to the chain. Okay, so molecule E, the 1-methylpropyl, we call sec-butyl. Now notice that sec is in italics, and there's a dash between sec and butyl. Incidentally, when you're alphabetizing isobutyl, you alphabetize isobutyl under I, but the sec does not count when you're alphabetizing it, because sec is short for secondary. If you look at carbon 1, the carbon bound to the parent chain, it is bound to 2 other carbons. Therefore, that is considered a secondary carbon. We're going to see this concept of secondary, tertiary come back again when we look at some other different functional groups. Okay, so the common name for this is sec-butyl because of the secondary nature of carbon 1. And one of my students that I taught a couple of years ago thinks about it, especially when it's drawn this way, as looking like half a house. Okay, so you see how the methyl group in carbon 2 looked like the roof line, and then going down between carbon 2 and carbon 3 looks like one of the walls of the house. It's just missing its left-hand wall. So if it helps you, you can remember a sec-butyl group as being half a house. Okay, then finally getting on to molecule F. What do we do with this? Well, it's still a butyl group, and if you look at what we did with molecule E, I think you'll know what to do with molecule F. Because now carbon 1, rather than being a secondary carbon, carbon 1 is a tertiary carbon because there's 3 other carbons in addition to the parent chain bound to carbon 1. Okay, so instead of being sec-butyl, this compound is called 6-tert-butyl dodecane, where tert is the short form of tertiary. Once again, tert is in italics. It is separated from the word butyl by a dash, and it is not alphabetized as tert. It is alphabetized under B.